So as I said in the last video, we're going to be skipping over trapezoids to talk about kites next. And the reason for that is kites are a little bit simpler, and we should be able to get through kites in the same day as squares and rectangles. So kites go in this last box over here. I'm going to put kites right here. And there's actually like a small subcategory of kites called darts. That's this shape right here. Kind of looks like a weird Star Trek logo. That's called a dart. And all a dart is an inverted kite. Technically, the term is concave. It is a concave version of a kite. And one thing that kites, and by extension darts, have is that they have no parallel sides. No parallel sides. So 0 sets of parallel sides. They have 0 sets of parallel sides. So that differentiates them from parallelograms because parallelograms have 2 sets of parallel sides. Kites have none. We're going to talk about a little bit of the differences in just a second. Once you have that copied down, go ahead and flip to the page on kites. That is after trapezoids. Again, if I'm going too fast, slow down the video, pause it, rewind it, whatever you need to do. Go at your own pace. Okay. So like I said, a kite is a quadrilateral with no parallel sides. None. It doesn't have any parallel sides. But it does still have 2 sets of congruent sides. So in a parallelogram, those congruent sides were opposite each other. In a kite, they are not opposite each other. They're next to each other. So in a kite, these sides here are congruent, and these sides here are congruent. So the way that we describe those sides is by saying that they are sets of consecutive congruent sides. Consecutive because they are next to each other, and congruent because they are, well, they're congruent. They're the same length. So we have 2 pairs of consecutive congruent sides. In this case, we have segment KI, which is congruent to IT, or TI. That's those 2 red marked ones. And we also have segments KE, congruent to TE. Those are my 2 sets of consecutive congruent sides. Now, parallelograms also have, with their two congruent sets of sides, they have 2 congruent sets of angles. With kites only have 1 congruent set of angles. 1 congruent set of angles. So they have only 1 pair of opposite angles are congruent. Now, I want you to pause the video and see if you can guess which angles are congruent. So there's only 1 set. I want you to see if you can figure that out. Okay, so I think that the easiest way to show which angles are congruent is taking a step back and looking at the previous unit that we just did, Unit 5. I'm going to go ahead and draw in one of my diagonals. I'm going to draw the diagonal from I to E. It's not very good, but I'm going to draw that again. I to E. That's better. Okay. Now in this case, I have 2 triangles where I'm given that these sides are congruent and these sides are congruent. I don't need you to draw in this, just so you know. I just want you to watch what I'm doing. I'm also told, since this is a shared side, or I'm not told, but I know that since this is a shared side in the middle, that side is the same as itself. So, by the side-side-side congruence theorem, triangles KIE KIE and triangle TIE are congruent. Then, since corresponding parts of congruent triangles are congruent, I know that angle K is congruent to angle T. So I'm going to mark that, and I want you to fill that in on yours. Okay. You don't need the little markings here. You do need the diagonal, because we're going to need to draw that in a minute anyway. So we know that angle K and T are the same. And we know that angles I and E are not the same. They are not congruent. So angle K is congruent to angle T, but angle I is not congruent to angle E. Probably the easiest way that I would say to remember that is that the angles between the two sides that are different, those are the same. So these two sides are different, they're different lengths, and this angle lies between them. These two sides are different lengths, and that angle lies between them. Those two angles are the congruent angles. So I'm going to write that down a little bit more formally, but just know that this is what that means. That the sides, or the angles between the non-congruent, that just means that they are different. They're different lengths. So the angles between the non-congruent sides are congruent. So all that's saying is that angles K and T are congruent because they lie between the two different sets of side lengths. Next thing we're going to do, we're going to fill in our other diagonal. So we're going to draw a line between K and T. And you can go ahead and put a point in the middle there. And we're going to call this point A. And the first thing we know about the diagonals of a kite is that they are perpendicular. This is true of rhombuses, and this is true of squares. But it's also true of kites, that the diagonals are perpendicular, which means they intersect at 90 degrees. So there's an angle right here. Angle EAK is 90 degrees. And in fact, not only is EAK 90 degrees, but all of those angles at K are 90. So all angles at A are 90 degrees. All of those angles at A are 90 degrees. Now the last thing that this tells us is that the longer diagonal bisects the shorter diagonal, which in this diagram tells us that KA is congruent to AT. And that's true a lot of the times. That's true most of the time. The exception to that is if our diagonal is the exception to that is if our kite is shorter than it is wide. So if I had a little kite that was like that, and that's the short diagonal, and this is the wide diagonal, well then the longer diagonal is being cut in half. It just depends on the dimensions of your kite. So this is true most of the time, but occasionally it's not. And the way that we get around that is by saying, really, the diagonal that goes between the two congruent angles is the one that's being cut in half. So the diagonal between the two congruent angles, so in this case that's angles K and T, the diagonal between the two congruent angles is cut in half by the other diagonal. So that means that segment KA is congruent to segment AT, and we're going to mark that on our diagram. Segment IA is not congruent to AE. Those are different lengths. There's only one set of diagonals that the halves are congruent. Because A is not the midpoint of IE. It's only the midpoint of KT. Okay, I know kites are a little bit more tricky, a little bit more confusing. But that's kites.